Okay, today we're going over an 820-3662 Retina board. What makes this board a big pain in the dick is that there are no schematics or board views released for this, meaning that I have absolutely no idea what is going where on this board, and as you can see, there's a lot of components in this board for those who are not familiar with this channel, so you can look under the microscope here and see that there is a lot of stuff going on here, a lot of interconnected pieces, and yeah, I have no idea what any of them are for or what any of them do, because there is no documentation. So one of the big problems in this business is all of these schematics are, I'm not going to say how people get them because I don't know, but I'm pretty sure they're not supposed to have them. And yeah, that's what sucks. So the problem that we have on this board is that it works on the battery just fine, but it doesn't work on a charger. So if I plug a charger in, I get no light and it doesn't turn on, and that's the problem that we're going to be looking to solve. Now, one of the things I say on a lot of these machines is that you need the one-wire circuit is what's going to allow the charger to talk to the SMC. If you don't do that, you have no green light in the charger. So what you need for that to work is PP3V42. I'm pretty sure that the SMC is fine because when you're using this on a battery, it functions perfectly fine. It doesn't run slow. It doesn't give you any of those sensor issues. I have videos on sensor issues, so you can see what that's about if you're kind of confused as to why I associate sensors with an SMC. So the first thing I want to do here, again, I don't have a board view, I don't have a schematic, so I kind of have to go based on what I know from other boards. So what you can see over here is the PP3V42 region is over here. Now, remember, PP3V42 is one of the only power rails in the machine that can have multiple inputs. It can either be powered by the charger or the battery, and this diode over here is meant to keep the charger and the battery from powering it at the same time. Obviously, if that happens, bad things will happen. So if it's on the battery only, you're going to see power going through here. This is PP bus G3 hot on one side, and on the other side, it's going to go over here. Now, if it's plugged in, it's creating PP bus G3 hot for the machine to work, but it also has charger power, so it's going to be powered off of both, which is why this diode is here, so only one can go through at a time. Now, these two look just fine. So let's just measure just to make sure. And again, I'm guessing. I don't know if that's the PP3V42 circuit. I could very well be wrong because I don't have a schematic or a board view because Apple doesn't see fit to allow me to fix their products. They would rather you spend $1,200 on getting it fixed with them. But let's see if we can outsmart them. So over here I have a 10 ohm resistor and a 47 ohm resistor, which is the exact same thing that I see on other boards for the PP3V42 circuit. So this tells me one of two things. Actually, two things. A, my PP3V42 circuit is most likely fine in both creation from the battery and the charger. And B, that is the PP3V42 circuit because the values match very closely. So now let's see what happens when we actually plug a charger into the machine. Let's see what we measure. So I'm going to grab a charger over here. Okay, now again, we have no green light. So the first thing I'm going to do is I'm going to measure voltage on the charger. So I'm going to get my multimeter in voltage mode. Now, on the actual charger, let's make sure that that's working. I get 16.55 volts, which is perfectly acceptable. Now, on the input for PP3V42, I get 0 volts on both, which is obviously unacceptable. So somewhere between the charger itself and there, something is not working. So the one-wire circuit is not telling the charger not to work. It's not putting it into a protection mode or setting it to 0 volts in any way. It's just the power is not making its way through to the machine. So let's take a look on the actual DCN board and see around the DCN board area what we have. So where is power stopping coming in here? So here is what I would imagine to be the DCN fuse. And I have 16.55 volts on this side. And on the other side, I have 5 volts? Okay. This never happens. That fuse was bad in one video I've done all year. Let's see if there's a short to ground on either side of this. So I'm going to take my multimeter. When I say test for a short to ground, I put it in diode mode. I take the red probe. The red probe goes on ground, which can be the coating around a screw hole. The black probe is going to go on the area where I want to see if there's a short to ground. Now remember that you cannot have power plugged in when doing resistance mode measurements or diode mode measurements. You cannot have these plugged in because that will mess up everything, including your multimeter. Now when I touch the pins of this together, I see 0 voltage drop, so my multimeter is working. But when I touch each side of the fuse together, I get OL, which means that fuse is actually bad. So this is kind of funny. Like the reason I find this humorous is on a board that Apple has gone above and beyond to make sure that nobody knows how to fix, that the problem that I'm having, the first one of these I'm actually fixing, it's literally the fuse. It's like the simplest problem in the world. So again, fuck you for not releasing the schematic, and fuck you for trying to make life hard. So what we're going to do here is I'm going to put some Kapton tape over the DC inboard connector because I don't use hot tweezers. I don't use any of that stuff to replace small SMD components. I prefer hot air because with hot air, you don't really have to have a perfect steady hand. If you know how soldering works, you can get the component to just sit in place using surface tension. So it'll look like it was soldered pretty well by somebody with very steady hands, even if you're a complete mess. And I'm a complete mess. So let's just cover this in Kapton tape because you don't want to give boards back to people that have burnt connectors and burned stuff. I try to avoid that whenever I can. It just sends the wrong message. It kind of, even if I do care about what I'm doing, it sends the message that I don't give a shit. So cover it with my Kapton tape. We're going to wait for the hot air to heat up. You know, while I'm waiting for the FR801 to get hot, because it takes a while since it's actively blowing air through the heating element, so it's kind of cooling it as it's heating it. So while I'm waiting for that to get hot, I'm just going to make it a little bit easier to do the job by adding some leaded solder over the fuse. Some flux. This is the wrong tip to be using for this, but all right. Let's get rid of all the lead-free junk. It's all going to get sucked up into that nice ball. Okay. Now I have a donor board here with well, I was about to say equivalent value fuse, but I can't say if the fuse is equivalent value because I don't have a schematic. So I have no idea what this one original value is, but it's got to be close enough. This is the Retina board with the GPU that I have here. So the 820-3662 that I'm fixing is the 15-inch Retina board that does not have a discrete GPU, that's Iris only. That fuse is now in the 6th dimension. Almost in the 6th dimension, I found it. Now, before I go about plugging it in, I'm just curious, measure my fuse, see that it's good. Ideally, since this is a fuse, I would read a 0 reading in diode mode, meaning 0 voltage drop from one side to the other. I read a 0 voltage drop from one side to the other. So now what I'm interested in doing is plugging it in. And when I plug it in, I get a green light. And now an orange one. So again, this is pretty cool. The reason I find this funny and ironic is that the entire point here, the entire point with not releasing the schematic for this board is to make it more difficult. And the CPU is getting warm, which is my... Like, I used to see that the fan spun. First, I used to see that it turned on. Then I used to see that the fan spun. Now I touch the CPU. I mean, I'm getting... You can tell that I'm getting a little bit tired of doing long-form content motherboard repair videos, but I digress. What makes this funny is that Apple goes through so much fucking effort to make it impossible to repair these products. And again, the first one I get, which is a board where for a long time there's been no schematic or board view, the first one I get that I really have to put effort into fixing is one where the only problem is the fuse. So it's kind of like, it's kind of like the cosmos is giving Apple a big fuck you for making life hard. For the repair technicians, a big fuck you for making life more expensive for consumers that would rather give me $300 or $400 than give Apple $700 or $1,200. And again, this thing was dropped off an hour ago. This person's going to be getting this back in an hour. So turnaround time, 2 hours. 1/3 to 1/2 the price of Apple. You get to keep all your data. I think that's pretty cool. Like, this person dropped this off on lunch break. They're going to get it back before the end of the day. And this is not to praise me. The thing is, you can get that type of service at a lot of independent repair shops. A lot of them. Service that you cannot get at Apple. Service that is not feasible to provide at Apple. You're not going to find, you're not going to find a time or a reality in which at an Apple store, every Apple store across the U.S., they're doing component level repair. You're just not going to find a way to standardize that. And if you can, God bless you, but you're probably not. And so you shouldn't rip away the resources from the people who are actually good at this so that they can do their job better. Because again, here's the thing. Like, I'm going to figure these things out without a schematic or a board view. Don't think that because you take the schematic or the board view away that it's going to keep me from knowing exactly how this thing works. I'll figure this thing out one way or another. I'll figure out what the components in the board are. I'll read the sample circuit diagrams from the manufacturer. If you take away those PDFs that have the sample circuit diagrams from the manufacturer or the data sheets where it shows you the suggested circuit, I'll look at the suggested circuit for another one of their chips that's similar. I will figure out how this is connected, whether you like it or not. Again, it's just a question as to whether or not you want to make it simple, whether or not you want to make it easy, and whether or not you want your customers who own your products to have a good experience when they go to fix them. Because again, if they had a good experience with you, what would they be doing here? If they went to the Apple store and you gave them such a great solution, why are they coming to this room? Why are they coming to a room where my chair is going over a hole in the floor, where there's, again, like where my bathroom door has a hole in it that has a box taped onto it? Again, like consumers, and I'm not trying to put myself down here, it's just the truth. Consumers would not be coming here. They would not be coming here at all if the alternative were a good one. So you have to think about just how bad the support is from the primary manufacturer when it is that people are coming to this dump, no offense to my space, to have this fixed instead of having it done at a shiny, beautiful, credible retail store. So you should stop taking the tools away from us that we need to do our job. Because again, you can take them away. I'm going to keep fixing them. Thousands of people across the world are going to watch this content and are going to learn how to fix them, regardless of what it is you do. So just stop trying to sabotage it.